So, this is a little embarrassing. Making all these lessons takes me about 1 week each. There is a lot of information to lay out, voice to record, and screen to grab. And in the last week's rush, I totally forgot one very basic and simple variable type, one I personally use frequently in my projects. I will quickly open the last lesson script to talk about the string. The type string can hold text. At the top of the struct, type public string brand semicolon and public string model semicolon. And when you declare the race car variable, call it car. Save and return to Unity. As you can see, the car now asks for a brand and a model. Let's change the line print BMW tank capacity plus liters to print the space plus car model plus space plus car brand plus space has a tank with space plus car tank capacity plus space liters. The string is used mainly to hold text data. If your string have numbers alone, they can't be used to calculate math. The number 5 in a string is just the fifth character that represents numbers in human language. But for the computer, it's not a number, it's a letter, like a letter, a comma, a space key, or whatever symbol you want to put inside. It is not a number, it's a word, even if the character is the character 5. In Unity, you can set the car's new tank, brand, and model. At play, it will write, the M4 BMW has a tank with 60 liters. Let's start by creating a Unity project. The project is 2D, and I will call it Me Little Robo. You can download the assets I'm using in the link in the lesson's description. We will start to make a more complex game in order to understand a real-world application of the Unity's engine and the components and the scripts and all of the stuff I have already talked about, among many other things. The rest of this series will be the construction of a game, and it is imperative to follow all the video lessons in the right order to understand why something is there. So, let's talk about our game. I will make a 2D, sprite-based open-world survival game where you try to fulfill your needs to keep your systems alive. It's a top-down view, and you can go up, down, left and right in a fake perspective world. The last human has died, but right before that, his little pet robot has made a sacrifice by downloading his owner's mind and mixing it with his own in order to keep him alive. The human part needs to adapt to his electronic and metal body, and his computational CPU needs to deal with a whole new set of feelings. Mechanically, the gameplay will focus on the robot movements and interactions. So, we need to make the robot move in all directions and detect other objects around them to interact with. We will also need to have an inventory system to collect the objects we find. Parallel to this, Robo slowly dies unless we do something to prevent that. We cannot allow the robot's battery to drain. The player needs to find a way to recharge it before it reaches 0. I'm going to focus on the main character's movement and animation. We should use placeholders in a prototype phase, and I will do it with other elements of the game. But I guess we can give this character a different treatment from the beginning to have a sense of the mood of the game. I will create a script to control it, the animations, and the GameObject prefab at the end. Let's start by creating some folders we need to organize our project. Animations, prefabs, scripts, and sprites. Download the zip file with the assets and unzip them to the sprites folder. Unity will import them as soon as you return to the editor window. If you drag one of the sprites to the scene, you will notice the size is too large for the camera. The best solution is to set up some sprites parameters and not to scale in the transform. Select the sprite in the project window to see it in the inspector and set pixels per unit to 300 and max size to 1024 pixels. Click on Apply and leave the rest of the options as they are for now. To animate this sprite, we need to set a skeleton and assign the bones to the correct parts. To do it, you go to the Sprite Editor. On the Sprite Editor menu at the top left, you change the mode to Skinning Editor and turn on the Visibility panel. In some cases, the editor ignores the shadow because of the transparency and doesn't create a geometry to draw it. So, the first step is to get back that shadow by selecting Auto Geometry, assuring the alpha tolerance is set to 0, and regenerate the geometry. Now we have the shadow that will be the ground base for our character. To create a skeleton, we select and start by the main bone, the one we will use to put the character in the world and as a base to all of the other bones. So, double-click the shadow to select the sprite, and from its center, click, drag up a little, and click again to finish the bone. The next bone is already connected, but in this case we don't need that, so right-click anywhere to unlink. To make the body follow the shadow, we select the first bone. Now you can see this ghost connection indicating the parent. Create a bone from the center of the body's base to the middle of the body. And keeping the connection, create another bone to the center of the top surface of the body. Right-click to stop this connection tree and select the upper body bone that will be the structure for the eyes. First one, and then another. Now select the shadow bone and create a bone for each foot, more or less around the center of the base to the center of the top. Once it's done, right-click to deselect. We can ramp up the quality of the model. We should not do this for all the characters in the game because it will increase the processing, but this is the main character, so I guess it's okay. Select Auto Geometry and set the outline detail to 95. Subdivide to 100 and regenerate. You can see that we have a more detailed geometry and that the triangles are now color-coded. Those colors represent the influence of each bone. If you go to Preview Pose, you can test by yourself this geometry affectance by rotating a bone. Normally this works fine, but if you need to tune the values, you can go to the Weight brush, select the bone, adjust the hardness to a low value, and start to paint the vertices. Once the character has these weights adjusted, you need to reorder the bones to the correct depth position and rename to better identify them later. Shadow is the background, so its depth stays at 0. On top of the shadow we will have the feet, but the right foot is in the background of the left foot, so the right foot should have a lower depth value than the left foot. On top of that is the body, which has two bones with the same depth. Now the right high is in the back of the left high, so right goes 4 and left goes 5. Click on Apply and close this window. Everything looks the same. Now we need to add a script to allow us to create the bones here in the scene editor. Select the robot in the hierarchy panel and in the inspector add a new component called Sprite Skin. Inside, you click on the Create Bones button to populate the list automatically. The first step is to assemble the creature. Select the shadow bone and set 0, 0, 0 in the transform position variable. This is very important to avoid the central point of the shadow, where your character is on the ground, having any offset. Bring the body to the top of the shadow and drag it up a little. You can drag the feet to the ground. Imagine a line passing through the base of the bones with the same inclination as the drawing's perspective. And now do the same for the eyes. This is the base. From here we can make the animations needed to give some life to our character. I will start with the idle animation. Idle is when the character is just standing still. It should move a little. Being extremely static is just boring. Go to the animation folder and create animation. Call it idle back and drag it to the robot. As you can see, an animation controller was automatically created. This animation controller will have all the states for this game object, but for now it only has the idle. Let's animate the idle state and a walking state. As you may imagine, there is no limit to how many states you can have. Return to the scene, select the character and in the animation panel click on the red button. This will make the animation record any movement you add to the bones. Drag the cursor to the 30 frame and move the body down just a tiny bit. Now copy the first keyframes to the 1 second position to make the movement flawless when looping. Hit play and watch for problems or improvements. If you are happy with the movement, do something similar to the eyes. Now that we have all the movement, we can disable the record button and create a new animation. At the top left of the animation panel, you have this menu where you can select Create New Clip. Navigate to the animation folder and call it Walk Back. I will start by putting the feet in a middle step position at the first frame. I drag the left foot forward, respecting the perspective, and the right backwards. I will copy these keyframes right now, and at the 30 frames mark, I will do the opposite. If you hit the play button, you can see the robot dragging his feet. To make it raise the foot, make it go up some frames after the foot is at the back. You can also add a little rotation forward, but don't forget this is not 3D. If the values are too aggressive, the perspective will change dramatically to something that doesn't look right. You need to make sure the foot rotates only when it's in the air. By making the angle 0 from the first to the last frame, the foot is on the ground. You can even make the heel go first, by rotating back before touching the ground. but in this case you really don't need to worry about the hidden foot. Now let's take care of the body. The body should go down a little after the foot touches the ground, like the weight being applied on a leg. Also, every time the foot goes up, the body should follow. Let's try to apply these concepts. This is already down position. Let's raise it with the foot. Make the position be as in the beginning at the end of the step. And maybe lower it a little bit more just before the step. Now we can make the upper body rotate a little back with every foot lifting and forward before the step. This gives the character a more cartoonish look, but that's okay for the style pursued here. Maybe we can also do that to the bottom part of the body. Let's try. And of course, don't forget the eyes. Once you are happy with the movements, remove the record button, select all keyframes and rescale the entire animation to make it faster. You can actually set the speed later, but this way we already have a standard fast pace. Now that we have these two animations, let's open the animation controller for this game object and program the parameters and transitions between the animations. To make the animator select the correct one, we need to tell it about it. On the Parameters tab, click on the plus sign button and choose Trigger. A trigger is like a boolean that is always false unless in the frame you trigger it, and once it's triggered it goes false again. So it works like a push button. The first call it idle and the second walk. Now right-click on the Any State node and make a transition to both actions. If you click on the arrow, you can set how this arrow or transition happens. So from any state, like idling or jumping or dying or whatever you need in your game, from any state to walk, a transition will happen every time the walk trigger is activated. And by the same logic, the idle animation at the idle trigger. I will drag this animation controller to the console dock so we can see this in action. First, select the animations in the project panel and set them to loop time and loop pose in the inspector. Now, if you run Unity and trigger the parameters, you will see them changing accordingly. As you can also see, the transitions are smooth. Unity will blend the animation in order to hide any jump cuts in the movements, and that's why I was able to start the walking animation with the left foot at the front. We can adjust the timings of those blendings by changing the duration of this crossfade in the Transitions inspector. I'm triggering these parameters by hand, but eventually the script that will make the robot move will also call the correct animations. So the next step is to build the game object of the character with all the needed components. Up here in the hierarchy you have this RoboBack game object. This will be just the back view of the character. The main game object will have to deal with both views later. So let's create a parent game object to hold this and other necessary things. So right click, create empty and call it Robo. The Robo object has to be at 0 before dragging everything inside. Once done, create a new script called Robo and add it to the main Robo game object. This is the script that will control the robot. Edit the script and let's start adding the movement functions. To deal with movement, we are going to use the transform.Translate function. If you don't know how to make something in Unity, you can go to Google and search for it. For example, Unity move character or Unity move 2D character. You will find many approaches to this problem, but let's focus on the transform.Translate, that is the one I'm going to use here. If you don't know how to use the transform.Translate function, you can select this site over here that has all the information you need to use the functions, methods, and whatever Unity has. The translate is expecting a vector3 with the direction of the movement. So we create a vector3 variable called movement, vector3 movement, another variable to hold the speed, serialized field float walking speed equals 3f, and at every frame of the game we send the direction vector to the translate function. So on the update we write transform.Translate movement dot normalize times walk speed times time dot delta time. We multiply any kind of movement by time delta time to make sure that the speed will be the same in every computer. If it's a faster computer, this will be a lower number, so many times per second, but small increments. Or if your computer is slow, you have less frames per second, but bigger frames, so a bigger increment. The result is the character will move apparently at the same speed in every computer. Okay, the movement is a vector3 and the walk speed is a float. Why there are no errors by multiplying a vector with a float? Well, inside the vector struct there are 3 floats, and the multiplication operator is programmed to multiply it by every single float inside the vector3. This will not produce any movement yet because the movement vector is 0, so let's change that with the arrow keys. I'm going to use the Input Manager because this is a beginner lesson, but eventually consider using the new input system. Movement.x equals to Input.GetAxis, open parenthesis, the name of the axis, horizontal, semicolon. Movement y equals Input.GetAxis, vertical, in the beginning of the update method. This should make the character move around the screen, but without the animations. An easy way to change from idle to walk would be to use the movement's magnitude, which is the size of the vector, as a reference, and if it is 0, it's because it's idling, and if it's not 0, it's because it's walking, positive or negative direction. So, we make a reference to the animator, serialize field, animator back body anim, and a variable to hold the trigger we need, string next animation. In the update, we check if the movement is not 0 and set the next animation accordingly. If movement magnitude is higher than 0, next animation equals walk. If movement magnitude is equal to 0, next animation is idle. Note that in these if statements I'm not using the curly brackets. Well, if you only have one thing after the if, you can write it like this, but if you need to do more than one thing inside the if, you really need to have the curly brackets to enclose all of the actions you want to take. At last, we send the trigger value to the animator controller. Feel free to pause here and think why this will not work properly. Well, if we are sending every frame a trigger, the animation controller will start from the beginning at every frame, and the animation will not play. To prevent this, we need to send a trigger only if it is a different animation. If you trigger idle, 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 etc. every frame, the animation will play the first frame forever. To check if the new animation is different, we need a variable to keep the current animation and compare them. String current animation, and now we can test if the animation is different from the current one. If it is, we trigger it, but if it's not, we don't send it to the controller. After sending a new animation, we update the current variable to have a correct current state. So, if next animation is not equal to current animation, back body anim set trigger next animation, and current animation equals next animation. This will trigger the next animation, idle or walking, and update the current animation to that, so this will be false next frame and we will not be respawning the first frame every time. But now you say, oh, but when I go to the right side, the robot looks like it's moonwalking. Where is the sprite turned to the right side? Well, we just need to flip this one, and now it's turned to the right. But to do this automatically, we need a reference to the sprite renderer. Serialize field, sprite renderer, back renderer. And set the flip to false or true according to the direction. If it's negative or left, the flip is false, and if it's positive, it's true. If movement x is lower than 0, back renderer dot flip x equals false. If movement x is higher than 0, back renderer dot flip x equals true. Notice we are testing the x value of the movement, which is the horizontal axis. In Unity, don't forget to add the robo back to the variable of the sprite renderer. Now everything looks okay, but when walking down, the robo stays facing backwards. Well, this will take a little more time to work, because you need to do the same thing for the other sprite. Create the skeleton, adjust the weights, build the body, animate an idle and a walking cycle, and only when that's done, we have the material to continue the script. Let's just repeat the process until we have the robot front done. When working on the front sprite, disable the other in order to have a clean scene and not drag the incorrect element. Once the rigging and the animations are ready, you can drag the robo front to the robo main parent and enable it. Both views are visible and getting in the way of each other. Let's disable the back view and prepare the script to receive this second GameObject. We had a new reference to the animator and sprite renderer. Serialize field, animator front body anim, and serialize field, sprite renderer front renderer. And also the code to flip the sprite according to the horizontal direction. Front renderer flip x equals false. Front renderer flip x equals true. If we trigger idle to the back view, the front view, even if it's hidden, should also receive the same command, so they are both synchronized. Front body anim set trigger next animation. Now we have to enable the back view when we go up and disable the other, and the opposite behavior when we walk down. Similar to the horizontal directions, we use an if statement to check if the value of the vertical axis and use those results to enable and disable the correct sprite. If movement y is lower than 0, back renderer enable is false and front renderer enable is true. If movement y is greater than 0, back renderer enable is true and front renderer enabled is false. As you notice, we are not disabling the whole GameObject, we are just disabling or enabling the sprite renderer. If you return to Unity, you need to enable the robo back again, but you will have them both until you play. The disabling of the incorrect one will only work after you start moving because the if statement tests different from 0. The solution is to assure that the start method setups the correct direction at the beginning, not only to the vertical axis but also to the horizontal one. In the next lesson we are going to add the necessary components to make the character interact with other objects, like colliding with them or connecting to them and passing information. I will also have new assets to add to the game and populate this little world with more than a void. Also check this video's description and follow the links there to other tutorials with more information on this subject. So, I hope you learned something new with this lesson and I'm expecting to have you in the next one. Bye!